This is Unit 2, Segments, Lines, and Angles. Preview video 2.1, Graphing of Lines. Sit tall. Through your nose. Ready? Inhale. Hold for 3. Birthday candle 5. Let's do it one more time. Ready? In through the nose. Hold for 3. Exhale 5. You just close your eyes and sit there for about 20 seconds to the end of the music. Eyes closed. Breath. Your eyes. Why do you close your eyes? It helps still your mind. Most of us, we're constantly stimulating our brain with our phones, homework, videos, television, and just a few seconds of quiet with your eyes closed, doing absolutely nothing, helps your central nervous system just go, ah. And once you alert, once you calm, and let's ready to go. For this lesson, which is graphing of lines, you're going to need some sort of straight edge. So you should already have a ruler of some sort in your equipment. And if somehow you've forgotten it, I provided a tongue depressor for you. So make sure you have that on hand. Date, time, and location. Don't forget a parent's signature sign off. Please do not attempt to multitask while you're doing this. Let's recap our previous lesson. I want you to do this page, pause the video, you start with the red pen. Ready? Pause. Welcome back. You should have a red pen handy, friends, and you are correcting your work. And remember, if you're correct, I expect some sort of acknowledgement like, woohoo, I got that done, or check, or smiling. And if it's incorrect, I expect some sort of written note. What happened? Totally fine to get things incorrect on this practice homework, as long as you write a note, what happened. So right here, I'm just going to give you the answers. That's going to be 2. So this is 10. That's 5. This is 30. That's going to be 5. 4 times 5, 20. Root 3 times root 3 is 3. 8 times 3, 24. Coming this way. What times root 6 is 6? That's another root 6. And this is a root 5 because that gives us 5. 2 times 5 is 10. You should be able to do these nearly instantaneously now. If not, come see me in class during tutoring. Give me 3 minutes flat, and I promise you'll be never intimidated by this again. We'll do a one-to-one exercise. We're talking about lines. This whole unit is about lines, pieces of lines called segments, and then we're going to start putting parts of lines together called rays and making angles. Vocabulary: rate, slope, y-intercept, x-intercept, slope, intercept form of a line, point, slope of a line. What is a linear equation? A linear equation is one that takes data points to create a predictive formula corresponding to graphs, and linear by definition is a line. Anything that has variables y to the first and x to the first, technically just x or y, is a linear equation. Versus when you start getting stuff with x squared or y squared, anything with x squared, y squared, you've just got curvy stuff going on. Parabolas, circles, ellipses, hyperbolas, all kinds of fun things, okay? So slope is rise over run. The slope of a line, the slope of this angled wall here, the slope is going to be the amount of rise, which is up and down, with the amount of run, which is horizontal. Rise over run. So let's do this together. Put your hand in front of you. We're going to do this 3 times and you're going to gesture 3 times. Slope is rise over run. Slope is, let's do it. Rise over run. Slope is rise over run. When we talk about slope mathematically, the rise is associated with the y-axis. The run is associated with the x-axis. Couple things I use to remember this. Say it 3 times. Rise, wise. Rise, wise. So just keep rise go like this 3 times. Rise goes with the wise. Rise, wise. Rise, wise. Run goes with the x's. Run, x's. Run, x's. Keep that in mind. We're going to come back to that in just a little bit. Now, when we talk about slope, there's 4 kinds of slopes you need to be familiar with. Positive, negative, zero slope, no slope. Positive goes from left to, we read graphs left to right, just like reading words, left to right. And when a slope tilts upwards from left to right, it's positive. When it tilts downward from left to right, it's negative. Right here, put rise over run. When something is horizontal, it has 0 up and down motion. So it has 0 rise over whatever the run number is. 0 rise. So a horizontal line has 0 rise. 0 over anything is 0. So 0 slope is always going to be a horizontal line because it has no rise. Right here, rise over run, rise over run. A vertical line has only rise. So there's a number there and it has no left or right motion, no left or right motion. Because it has no left or right motion, it has a 0 in the denominator. And only God gets to divide by 0. So a number over 0, we call that undefined. This is also known as no slope. Do not mix these 2 up. 0 slope and no slope are not interchangeable. More vocabulary. Y-intercept. The y-intercept is where x is 0 and y is a number. The x-intercept is where y is 0 and x is a number. So this line right here, its y-intercept. Y-intercept is going to be 0, -3. And your x-intercept is going to be 4, 0. If I told you to graph x equals -3, x equals 5, and x equals 8, watch very carefully. X equals 3, -3. X equals 5. And x equals 8. What I just did was incorrect. What I just graphed, and I'd like you to do this, I graphed the point 0, -3, 0. I graphed the point 5, 0. I graphed the point 8, 0. What I just graphed was 3 points. I did not graph lines. So how do you graph x equals -3, the line? This should read -3 comma something. So what you're looking here, it reads like this. All the points where x is -3. Say that with me. All the points where x is -3. So the easiest way to graph the line is start graphing a bunch of points that are at -3 comma something. We'll start with what we started, -3, 0, -3, 1, -3, 2, -3, 3, -3, 4. And you can see, using your straight edge, that the line is vertical. And this is x equals -3. All the points where x is -3. Notice that the slope is undefined. X equals 5 is all the points where x is 5. So 5, 0 is 1, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. Straight edge. This is x equals 5. Again, the slope is undefined. Last one, x equals 8. Technically, that's 8 comma something. That's going to be 8, 0, 8, 1, 8, 2, 8, 3, all the points where x is 8. Using a straight edge. X equals 8. And again, the slope is undefined or no slope. So be very careful. X equals -3, x equals 5, x equals 8 are not points. They're lines. And then you could guess if we were to do this, let's say y equals 5, that would look like this, 0, comma 5. That would be incorrect because that's only a point. So all the points where would look like this. It'd be a horizontal line. 5, 0, 5, 1, 5, 2, 5, 3. So y's are always going to be horizontal lines. That's going to be y equals 5. And my slope is 0 slope. So that's horizontal and vertical lines. The vast majority of our lines, however, are tilted one direction or another. And traditionally, we use y equals mx plus b. That's also called the slope-intercept form. Y equals mx plus b. B is going to be your y-intercept, and m is your slope. Always start by making sure you write the equation right underneath it. I'm going to show you how to graph this. I'm assuming you've seen this before. Taking a look here, we start by circling our B and circling what's right above it. And that's going to be +3. And that's the y-intercept along the y-axis. B is y-intercept along the y-axis. So that's B for ASL. Technically, it's with the right hand. Your B is the y-intercept on the y-axis. Do it again. Make a B. Your B is the y-intercept on the y-axis. One more time. B is the y-intercept on the y-axis. So we start here. There is your y-intercept, 3, 0. Our slope is rise over run, -3. This is super important. Slope is always a fraction. Slope is always a fraction because it's rise over run. So if you see a whole number, your run is automatically 1. Now here, a lot of students get really confused. Do I go up? Do I go down? Like, which way do I tilt this? Really simple. If it is a negative line, it's going to tilt downward from left to right. That's a negative line. If it's a positive line, it's going to go upwards from left to right. We are dealing with a negative line. So you know this line has to tilt downward from left to right. So my rise is 3, my run is 1. Watch. Rise 3. Run 1. Some of you just panicked. You're like, Miss Way, but 3 is negative. It doesn't matter, friends, which way you start that 3. What does matter is the final tilt of the line. So I can go up 3 and left 1. That's rise over run. Or I could go down 3 to the right 1. Again, rise is 3, run is 1. What's important, ultimately, is that my line must tilt downward from left to right. That's what's important. Always label your lines. This is y equals -3x plus 3. This is a negative line for a negative slope. Let's do a couple more. Always write your equation, y equals mx plus b. In this case, you're like, there's nothing there. That's kind of the point, friends. There's nothing there. Therefore, your y-intercept is going to be 0. Your b is your y-intercept. So your intercept is 0, 0. Now we do our slope, our rise over run. And it is a positive tilting line, so it's going to go up from left to right. I rise 5, 1, 2, 3, 4, 5, or I could drop 5, 1, 2, 3, 4, 5. But whatever direction I run, I must end up with a positive line. So I must run to the right. 1, 2, 3. Here I'd have to go to the left. 1, 2, 3. This is rise over run 5/3. Graph your line. Use a straight edge. Label it 5/3 x. And you can see it is a positive tilting line. Just kind of double check that. Positive, positive. Let's do another one. Y equals mx plus b. Our b is -4. Our b is always on the y-axis, so we are at -4 on the y-axis. That's going to be 0, -4. My rise is 1. My run is 3. And just make a mental note, it is a positive line, so I'm going this way. So from here, rise 1, or I could drop 1, run 3, straight edge. Y equals 1/3 x minus 4. Just check mentally. Positive slope, positive tilting line. Ready? You do the next 2 pages completely on your own. Pause the video. Welcome back. You should have a red pen now. Red pen. Let's take a look here. I'm just going to give you the answers. If you know what you're doing, you can just speed through and glance at stuff. Y equals -6. That means at -6, I have a horizontal line. That would be y equals -6. That's all the points where y is -6. Y equals +3. That's +3. Right there is your intercept. 0, -3. And then all the points where y is +3. That's y equals 3. Y equals 7. Right there. It's going to be 0, 7. That's the intercept, but the line is all the points where. So there's your 3 horizontal lines. Of course, the slope for all of them is 0. So the slope is 0 slope. Slope is 0 slope. Slope is 0 slope for horizontal lines. This graph here, y equals mx plus b. Your b is +5. This is a negative tilting line, so it's going to go like so. My rise is 3. My run is 2. So I can do like this. 1, 2, 3. Hang a left 2, 1, 2. You're like, Miss Way, it flies off the graph. Do not allow your brain to be confined by a pre-subscribed graph. You can go off the graph. That's 3/2. 1, 2, 3/2. It should look like this. Please label your lines. That's y equals -3/2x plus 5. Now, it's like, what's the point of all these lines? The point is that data points for lines can be predictive in nature, predictive in literally thousands of different situations, including healthcare applications, engineering applications, and financial applications, which we're going to do right now. We're going to read this out loud, my friends. Put your finger right there. Finger. Ready? Read out loud. All right. You should have read that out loud. Now, go back, underline, and or highlight using a pen or a pencil the key phrases. You have a loan, which is $1,200 in debt. Debt is a negative concept. You're in debt. So it's not a credit, it's a debt, which means technically that is going to be a negative number. Just keep that in mind. Debt means you're in the red, as we say. After 3 months, that's a time factor. You owe $800 at this rate. How long will it take to pay off the debt? In other words, pay off means get down to a balance of $0. Graph and express this problem as an equation, y equals mx plus b. You should have learned this in science, but you have cause and effect, just like conditionals, cause and effect. The cause is called the independent variable. The effect is the dependent variable. Independent and dependent. The independent variable is what causes something else to happen, and the dependent is what happens. So in this case, and the variables we use, cause is the x-axis variable. So your independent variable content goes on the x-axis. And your effect, also known as your dependent variable, goes on your y-axis. X is cause, Y is effect. Okay, now let's think this through. You have a $1,200 debt. After 3 months, you owe $800. Like, what changed? Well, what changed is you went from $1,200 to $800. That's changed, and it changed because of 3 months. So in this story problem, the time factor is the independent variable, which causes the dependent variable of debt to change. Ready? Now, we're going to take 2 data points. We have a loan of $1,200 debt. All right, at 0 time. So at the beginning of time, at 0 time, that's the beginning of the time, you have negative $1,200 in debt. That's your Y. After 3 months, so 0 months. After 3 months, you have $800 in debt still, and that's minus. Okay, so your X would be after 3 months, your Y would be 800. Now we're going to graph this, and we're going to get a Y equals MX plus B. Coming to the graph point, our 2 points are, we have 0 and negative 1,200. And after 3 months, we have still $800 of debt. So at the 0, we go down, and we're going to be at 12, negative 1,200. It says right here, your Y dependent, and it's funds in thousands. Okay. So 12, oh, it should say hundreds. Change that. That should be hundreds, not thousands, because this is 1,200. So there's our coordinate, 0, comma, negative 1,200. After 3 months, we are $800 in debt. So after 3 months, negative 800. Now we create our line, and we're predicting how many months will it take to pay this off. So we're going to find the Y equals MX plus B. Right here, we're going to find what our M is by finding our rise over run. Our rise that's 4 units to 3 units. So that means our slope is going to be 4/3. And we want to know how many months it takes. Our B, our original B, was 0. How many months is a factor of time does it take to get our Y to be 0 debt? There is your variable to get to 0 debt. So you graph. And at 0, excuse me, this should not be 0. At 0, this is going to be negative 12. So we solve. Because time can't be negative, 3 times 3 is 9. So we have 9 months. At 9 months, your debt will be 0. And if you take a look here, there it is right there. That is our predictive. At 9 months, our debt will be 0. So that will empower you to understand your budget. Don't forget to summarize the key things you have learned today.